want to read it over.
Your hair.
All right. So mean value theorem tells us it is very similar to Rolle's. It has to start out with the same first two conditions. It has to be continuous on the closed interval and differentiable on the open interval. But the third condition is different. It says that there is a number between A and B where the derivative at that number is equal to the slope between the endpoints. Okay? We think about what this is saying. So mean value theorem is allowing for these endpoints to be different. And if you found the slope between them, somewhere the derivative has to equal that slope. Or if you think about if you drew a line connecting the two endpoints, somewhere there would have to be a tangent line with the same slope. Okay, Rolle's theorem is really just a special case of this. In Rolle's theorem, those endpoints were the same. If they're the same, what's the slope between them? Zero, when we said the derivative was zero. So Rolle's is like a special case of the mean value theorem. So we can extend this now. All right, so I have given us a picture here. And it tells us, I want to look at this particular graph on the interval from 2 to 4. Can we kind of maybe figure out where the derivative would be equal to this slope? So if we think from 2 to 4. Right, so if you drew the line between those. All right, can we see that there would be somewhere between 2 and 4 where the tangent line would be parallel to this? Yeah, now we're trying to give it our best guess, so I don't know, what do you think? Right there?
Yeah.
Those two kind of look parallel? Is this exact? No, but I'm just trying to show you what it means. Alright, so this one, we're looking on the interval -1 to 3. Oh, so this approximate x value was about 3. It's about the number that made it work. Alright, this one, if we are looking from -1, we're down here, +3, we're up here. So if we took the line between those, we're saying somewhere we should have a tangent line that would be parallel to that. So what do you think that would be? Best guess. 1, 3 right here. If I drew the tangent line, there they are, approximately normal, so that x value was about at 1. The next two that I put on here are still graphs, but they don't meet all the requirements. What's wrong with this first one? It has a sharp curve. That means it's not differentiable right here. Okay. If we were looking from 1 to 4, and we took that tangent line, is there ever a place between 1 and 4 where the tangent line would be parallel to that? No. And that's okay because it didn't meet the requirements for the mean value theorem because it's not differentiable. Number 6, what requirement did this one break? Right, this is not continuous at 1. If we were looking from 0 to 2, this would just be a horizontal line. Between 0 and 2, is there anywhere where the derivative is 0? No. So again, this one didn't work. The reason being, it didn't meet the requirements. It was not a continuous function. All right. Let's do one using math, not just looking at a graph. So find the c such that the mean value theorem holds if f of x equals x cubed minus x on the interval 0 to 2. Anytime we're doing these, I would expect you to check criteria. Mean value theorem does have fewer criteria. It just has to be continuous and differentiable. What do you notice about x cubed minus x? Yeah. So if you just want to say it is a polynomial, so continuous and differentiable, that's enough for me to feel like you thought about your criteria. So in that situation where it is polynomial, that's all you really have to show me. Now, the mean value theorem says somewhere the derivative equals the slope between those two endpoints. So we need 2 points. When my x is 0, if you plug 0 into your function, what do you get out? When our x is 2, if we plug in 2, what do we get out? 6. 2 to the third is 8, minus 2 is 6. So the slope between those, y sub 2 minus y sub 1, over x sub 2 minus x sub 1, we get a slope of 3. So now, mean value theorem tells us somewhere the derivative is 3. So what's my derivative? So that would be 3x squared minus 1. And that has to equal 3. How do you get rid of a square? Square root. With that we need square root of 4 is 2. We can't do the square root of 3. So you have to get the radical off the bottom and you get 2 radical 3 over 3. Are both of those in the interval that I was looking at? I wanted to be between 0 and 2. So it said find the c value that makes this true. It's the positive one. Not that the derivative doesn't equal 3 at the negative, it just wasn't in the interval I asked for. Any questions on that one? So the mean value theorem is really saying that there's always a number where the instantaneous rate of change, or the derivative, is equal to the average rate of change, or the slope. If you think about it in terms of speed, so it's something we can relate to. If you drive a total of 120 miles in 2 hours, what was your average speed? 60 miles per hour. Would it be possible for you to drive for 2 hours, cover 120 miles, and never hit 60 miles per hour? No, you would have to have hit 60 miles per hour at least once on that trip. Does everybody agree with that? That's what it's saying. We're finding that one point when those two things are equal. That's what we're doing. Alright, so let's look at this one. Suppose f of 0 equals negative 3, and f prime of x is always less than or equal to 5 for all values of x. How large can f of 2 possibly be? Let's see. I'm going to add something. Suppose f of x is a polynomial. Because we know if my requirements aren't met, we can't say anything. Okay, so 0, 3, negative 3 is like an interval. The other one, my x is 2, and we don't know the y value. And we're trying to figure out how big can y be. So if it's a polynomial, the mean value theorem has to work. And the mean value theorem says that the derivative has to equal the slope between these things, right? So my slope between them, y sub 2 the biggest that could possibly equal? 5, because I told you the biggest the derivative can ever be is 5. See? I knew what you were doing. So y plus 3 over 2 equals 5. Y plus 3 is 10. And y equals 7. So the biggest possible value we could have for that y is 7. Just trying to get you to think about the mean value here a bit there. All right. Couple more things. If this is something we already know, if the derivative is always 0, that means it had to be a constant to start with. That's the only thing that has a derivative that's always 0. If you have two things that have the same derivative, then the only difference could be a constant. And those really aren't new things. We kind of talked about those with derivatives. And they're not really all that important here, but I thought I'd mention them again. So let's do one last example, like what you might be asked to find, actually doing the mean value theorem. I want to know if we can use it, and if it works, then let's try it. Can I just say this one's a polynomial? No, it's not a polynomial. So let's talk about our criteria. First criteria, it has to be continuous on the closed interval. Where is this not continuous? Negative 2. Is negative 2 in my interval? No. So that means it is continuous on the interval given. To check if it's differentiable, we should probably do our derivative. So I'm going to come down below and do that. So quotient rule. Low d high, derivative of the top, minus high d low, derivative of the bottom, over low squared. Okay, so could maybe do some fancy things and factor a little more here. So question is this differentiable? So let me ask you, where is it not differentiable? At negative 2. Is negative 2 in my interval? Nope, so it is differentiable. Technically it's differentiable on the closed interval, it only has to be on the open one. But either way, my criteria are met. So, we can do mean value theorem. Mean value theorem says that somewhere this derivative is equal to the slope between my endpoints. So I need my slope between my endpoints. So if I put in negative 1, opposite of negative 1 squared will give me negative 1 over negative 3 plus 6. Get negative 1/3. We plug in the 1. We plug in the 3. We get negative 9 over 18, which reduces to 3/5. Alright, so slope y sub 2 minus y sub 1, or x sub 2 minus x sub 1. So, negative 1 over 15. You guys better do this and check me.
I'm good there, okay, so.
14/15. No, negative. Just kidding.
I got -1/15.
Oh,
I went back and checked it again.
yeah,
I think you missed a negative.
yeah.
I had to redo it because I had the same answer.
Well,
What the heck?
I got -4/15.
15.
And then divide by 4.
Yeah.
Okay, so somewhere the derivative has to equal this. So we have our derivative equal to -1/15. Oh, this is going to be beautiful, isn't it?
No.
All right, let's go with it. We've got this. So if I cross, I am having a bad day, but this is fun.
No, it's not.
All right. So if can I square this and distribute my -1 at the same time? Sure. Thanks. You guys double checking me at all?
Well, right now I'm factoring.
Okay.
I'm on the 15 one. But I can't do that in my head.
So I factor out 36. What am I going to have to do now?
Factor?
Factor. Does anything multiply -1 and add to 4? No. So then, see, this problem is making me happy. My day is better now.
Oh, good for you.
Opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So we get 16 plus 4 is 20. How do you break down the square root of 20?
4 and 5.
Square root of 4 is 2. So then we can divide. We're getting 2 plus or minus the square root of 5. We were only looking from -1 to 3. So grab a calculator real quick if you need to. See if both of these are in the interval. So -2 plus the square root of 5 and -2.
2 or 36.
Well, does 36 ever equal 0?
Oh, yeah.
Or you could just think of it as dividing by 36, and 0 divided by 36 is still 0. So I think only the positive one works. So the only answer in the interval we were given is -2 plus the square root of 5.
Yeah.
That was perhaps some uglier numbers than.
Expected.
We know polynomials are nice and pretty, but rational functions are a little uglier. Any questions there? So yesterday we had the handout for mean value theorem and Rolle's theorem. So you have the other half of it to do. And
3, 2, 1, go.
okay, here's my next question. The next section is like gonna take us probably a good 6 days to go through. Would it be smarter to do a quiz before we get into a 6-day section?
Yeah.
Okay.
Dear
So,
God.
yeah, it's a big one. So quiz tomorrow. It'll
We do
cover
notes for 6 days.
sections 1 and 2.
Now you do homework and notes for 6 days.
Yeah, I'll break it up and I'm only going to do a couple examples each day. So, quiz has maximums and minimums on it, mean value theorem and Rolle's theorem. The mean value theorem and Rolle's theorem, they're really not all that hard, but make sure you look over your criteria. It's really just a lot of derivatives.